Checking that we're online. Looks like it. So give me 2 seconds. And all right. Hello everyone. My name is Miguel Ras. Welcome to the channel. I'll be giving you a brief number of tips and tricks on how to use the Julia REPL, which is on screen right now. So Julia is a super cool new open source programming language, and it started for technical and numerical computing, but it's general purpose now, and it's super easy, it's fast to learn, and it's very, very performant. So a lot of people are very interested in it, but they don't really know how to get around with using the REPL, which is what you're looking at now. So if you want to participate in this and learn a couple of cool productivity hacks and cool tricks about the REPL, stick with me, and we're gonna get through a list of like 15 of these and some recommendations for some cool stuff you can do. So this is the REPL. The only thing you need to do is to type in code, press enter, and then it will evaluate it, print it, and then it will do that again. That's why it's called a REPL, read, evaluate, print, loop, or something like that. So the only thing we need to get started with this, no matter what your computer is or operating system, just go to julialang.org and download the most recent. You can see the 1.3 RC3 or the stable version of Julia, and all of these should work no matter what you're using. So if we have that, the only other thing we need is our ducky, so that we can debug any of our problems, right? So this is the REPL. You can use it as a glorified calculator. You can define your functions. So this should probably give us 9. Yay! So now I will press Control L to clear the screen. Nice. So that's one of the ways in which I keep my screen quite a bit clean. So, you know, if I open up Julia, it's because I'm usually trying to plot something or try to solve a problem, see if an algorithm works, or try to implement something that I thought was cool, or just something to show off to my nerdy friends. And I'll usually run into a problem. So we're going to go over a few ways that you can try and help yourself, or get Julia to help yourself solve a problem. Right, so the very first one that you should probably learn is the question mark. If you ever input a question mark into the REPL, it will send you to the help screen. So if you ask it, hey, what does a parse function do? It will give you all these nice and handy examples, and that's the easiest way. If you don't have anybody around and Google's not working, or for some reason you're not connected to the internet, you know, the help function is your friend. And so you can ask it for any defined function that you've brought into scope, or that is if you've done using a package, or you just from base Julia. You can also ask about macros. Macros are these things with the @ sign. For now, I'm not going to talk about them. Just think about code with superpowers, because it can modify other code. And in really cool instances, you can even ask it about modules. No? So modules are, you know, the basic unit, one of the basic units for isolating how code, chunks of code. So you can ask it, and if it has what these things are, these examples, those are called doc strings. You can actually contribute to Julia. It's a really good and easy way to get started, and people are always helpful for people who contribute doc strings, right? So, but there's more to it. But sometimes if you do like passer, right? It says, oh, I didn't find that binding, and there's not really a good logic to it yet, but it says perhaps you meant parse, and then you can say, oh, all right, well, I meant parse. But sometimes you don't actually remember a function in a smart enough way for help to make a suggestion. So that's when you want to use the apropos function, right? Apropos, it will search through all documentation for a string. So I will do apropos dump, because I think that's a useful function. Oh yeah, it turns out it is. And then I can go and ask, hey, what does base dump do? And then it'll tell me, right? So it's like a glorified grep or search within the Julia code base, so that you can help yourself. But there's a really, really cool one that escapes a few people, and it's this one, right? So if you just type the open parentheses, maybe you don't remember, maybe you do remember the function name, but you don't remember what it applied to. So you can just press here tab, and it will tell you the different types of the arguments. So it could be like, hey, it's telling you that it will take an IO argument and then a regex argument, so you can filter even more out. Oh my god, I just learned something. I didn't know this function could take in a regex, a regular expression. No, I just thought it took in strings. So if this works for any function, not just the ones that define in base. So this one's defined for x, right? So a. This makes sense because in Julia multiplication is string concatenation, that's joining them together, and that makes sense because usually multiplication means an operation that's not commutative, like a times b is not the same as b times a, usually, mathematically, or at least that's one of the notations. So if I'm ever using, let's say, conjugate, I think it's conj, yeah, and I just type tab, then it will tell me all the things that it will apply to, right? And I'm like, oh wow, I didn't know that sparse arrays had something defined, had a method defined for that. Or sometimes you can be, we have this thing called an IO, and I can ask, what is this IO thing? And I'm like, I don't know, so what could possibly use this? So I do method, and then I'll say, maybe Julia can autocomplete this for me. So I'll go tab, and I'll do methods with, and then I'll do IO. So it will tell me, that's not very useful because that's a lot of them, but it will tell me all the places where it's defined, where a method is defined on that argument type. So if I ever load a package, right, and I want to know what their type is defined on, methods of foo, and if foo is defined in that package, it will tell me all the places where I can invoke foo as an argument, and then that will be useful information if I'm just trying to figure out how to work with the package. Like, where are all these things that I can just use this type information for, right? So the other super cool thing that you should probably know about Julia is that we have emojis, right? And emojis work as any other variable, and it is absolutely the coolest thing you could ever hope for. I mean, other languages have this too, right? But Julia makes it has made a very solid commitment to having internationalization efforts in its code base. So you actually, if you don't remember the name of an emoji, you can just start with a colon, then tab, and all of them are there. So let's say the surf is probably some dude there. There you go, auto-completed. Awesome, right? So that's part of my code now, I guess. And I mean, this is the eye candy for mathematicians and STEM people that just want to see Julia, and you're like, this is an amazing selling point. It's a total frosting selling point. It's it's not the be all and end all, but it's just such a quality of life thing. It makes everybody just happy to know that this exists. You can just use beta equals, I don't know, what's up, no? And just code will work. They're just normal variables, and so are emojis, and this is just amazing, right? And you can autocomplete for them. So you could do del, and it auto-completed if I press tab. Obviously I haven't defined it, so it'll tell me. All right, so now, so what's another way to get help? So usually you can try, help places, right? So places where you can get help are the discourse.julialang. Some other places where you can get help are the Slack Julia Lang and Stack Overflow, right? So those are places where if you Google it, you'll find a place where the Julia devs and Julia people who have made all the packages that you know and love have been there, no? And you can just straight up ask the person who created the code you're working on, hey, if that person's awake, and usually they're very kind with their time, you can just say hey, how does this code work? And if you're not asking for them to literally write out your homework assignment, you're probably to get a useful answer. But here's a caveat. You're kind of expected to work a little bit on your own and to try and make others' lives easier. What I mean, so they're going to come up with something that's called a MWE, which is the minimum working example, right? So, or minimal working example, I don't know. But the point is that if you try to do foo on, I don't know, A, and you're like, oh no, this is an error. I use your package and this function foo should have worked. So you'll go to their discourse, right, to their help places, and you'll say, hey, people there, I had this error and it didn't work. And if you just type out, hello peeps, I has mistakes, then that's unlikely to get a useful response. So what a minimum working example is you will copy paste this code. You will tell them how you defined A. So let's say A is 3, right? And then you would put it in a formatted way, like in backticks or something. You're like, this is my code, right? And then you're like, A is equal to 3, foo is equal to A, and then error, blah, blah, blah. Why not working? Help, please. Right? This shouldn't be running, but you know. Oh, it parses. I don't want to know why, but okay. The point is, you should probably try and format it so that others can help you. If you're using a package, then it's usually very kind, or if you're working on master, to include a version info. So maybe if you're in a not as orthodox version, hello, version info. Yeah. So we'll tell them what commit you're at so that they know what operating system you're running, like your architecture, if it's 64 bits, 32, what compiler, blah, blah, blah. All the stuff that people, all the basic information so that people can help you assess your problem, right? There's actually even an argument here for verbose equals true. And then that will give you a lot of information. Yeah, all the infos, right? And so some people will ask you for like your computer specs, and that's just a really easy way to include that in an error message, either on GitHub or in their packages or in the different channels, right? On the help places. And then that will probably help you, help them help you, if that makes any sense. All right, so all right. I'm just gonna give a shout out to one of my favorite packages that I use all the time is this OhMyREPL, because it just adds colors to everything. So I feel that it is absolutely essential that all my terminals have colors, because color coding is amazing and it just makes my life easier. And it also has this really cool perk where if you go and copy paste some code like here, I hope this works. You can paste it, and you see how it didn't paste it with a Julia at the beginning? So it makes it really cool so that you can just go and copy code from somewhere online, and you won't have to like be deleting like the money signs or the Julia whatevers. So that's really useful. No? Well, another really cool trick that I use all the time is this package called Benchmark Tools. Both of these packages were heavily contributed by Christopher Carlson, so he's a really, really awesome guy, and he's a very productive Swedish coder. And the staple of this macro is that anytime that you're trying to compare performance, because Julia people tend to be performance hackers, is you'll just try to do like, hey, like, you know, you'll do the @btime foo, and then this will tell you this will run the function. It'll get a bunch of statistics. It'll try to like make the measurements as precise and robust as possible. And then if you want to be fancier about it, you can say, oh no, actually, you know what? My setup should actually be x equals 4, right? So there's a certain way to parse this so that it's fancier, no? And you're not worried about these things that has to do with the @sign. And if you actually want to be a bit fancier, you can go into benchmark, right? And it'll spit out some more numbers, and you can crunch them if you want. But basically, anytime you want to check that if your function is running fast, just try and minimize the allocations and the bytes it's using, and then you're on your merry way towards being a performance hacker. Well, it's just like, what do you know? So that's one way to look at how your code is working. No, that's one way to know what's going on. One of the other really cool things that people miss out is the code lowered and friends. So if I do @code lowered f of foo, what this will do is it will try to tell me what Julia understood, no, when it parses the code. So this is like the first, from when you write your Julia code to like actual bytecode running on the machine. There's a few layers of abstraction that are usually impossible to look into and manipulate in other languages, but Julia is really, really cool because it's transparent in this sense where you can manipulate these data structures like with pure code, You can look at them, you can introspect them, and it's really, really easy to have like just a direct measurement of what it is that your code is affecting. I think of Julia as like being like a transparent engine, where like even if you're not a good mechanic, but you can see the oil running around and, you know, the pistons moving. And if it was all like, if a car engine was completely transparent, you know, as a programming language, that's what Julia feels like. Like you wouldn't, even if you knew nothing about cars, eventually you would know where the fluids would have to go. And that's how you start out in physics, and you end up worrying about compiler optimizations. So yay me, I guess. So this is one of the other really cool, let's say the next level down where you start from, probably, don't take my word for it, but there's just a couple of these, right? Code LLVM is the compiler backend that Julia has, and if you're interested, you can just go and say like, oh, what is it that my compiler intermediate representation is doing? And you can go and look at that. And then if you're really interested, you can go and look at the assembler that it spits out, which is interesting because a lot of people think that Julia is interpreted, and it's like, not really. It's like just ahead of time compiled or something close to that. Don't worry about the mechanics, but it's just when you care about your Julia code performance, if you just take care of 2 or 3 details, which are probably arguably things that you should care about, which are called type stability or type inference, then your code is just going to be like as fast as like handmade C code, right? Like those are SIMD vectorized registers, so like usually you would have to like bend over backwards to get access to these, and here's just like, oh, we just got you free compiler optimizations. It's part of what makes Julia cool, right? We're gonna go let me show you just one last thing where if you do code warn type, so those things that I told you that you have to worry about in Julia, that those type stabilities or type instabilities, those are really easy. Those become easier to look into and pick out of if you use this macro. It's called @code_warn_type. And if you ever have a really dubious function which isn't supposed to be returning 2 different types, then this is a really easy way. It'll just like pop out with red, like, hey, you have an any type here. And basically an any type is stuff that the compiler just said, I give up. I don't know what this is, and it just has to box it, and then just all the optimizations just go out the window. Your compiler just rage quits, just like, nope, I don't do this. It's like globals, just nope. So it just nopes out of there. So if you see any red code with code warn type, that's a really good idea. That's a really good indication that you probably have to split out your code into smaller functions. Don't worry about declaring types, and just try and use all of these dudes. The basic dudes to get all of your code stability is the L type, element type, the 0 for 3, and the 1, right? These are functions that will return like the 1, the 0, and the element type of the container or type that you like pass as the argument. And so I found out that there's like a really neat analogy to like what the Julians love to call generic programming, which is basically don't ever restrict your program unnecessarily, because if you write code that others can use, it will help you, like it will help everyone have like exponentially more useful code, because you will always like compose other people's code, right? So like stuff that grows on itself and others tends to have exponential growth. So the analogy to people who do physics is if you ever want to program in a type generic way, never talk about explicit types. So just talk about the 0s and the 1s and the L types and like generic functions. Just never get married to a type. And the analogy in physics is tensors. So tensors are a machinery that let you express equations and relations in physics without worrying about the coordinate system. Because when you get too married to the coordinate system, you start explaining things in terms of the coordinate system and not in terms of what the logic is. So that's like a just more holistic view. Like there's no like rough science behind it, but it's just like, it's funny where if you want to express things in a coordinate free way, just never use a coordinate system, use tensors. If you want to express your code in a generic way, never use types, use code generic functions, right? And those 3 are some of your best friends for that. All right, back to the random miscellaneous hacking stuff. So this is actually a credit to hackers. This is actually credit to Alex Arslan. I think he's like that on GitHub. And he mentioned that if you ever want to use emoji really quickly, what you do is you just say like, hey, I really need this emoji. So you autocomplete it and then you put it on the clipboard. That's a function that will send it to your clipboard on your operating system if it doesn't crash. Hello? And oh my god, I don't know why that didn't work. But then you're supposed to be able to copy paste it somewhere else. All right, so I failed, but I have used it. It does work. I vouch for it, right? There's this package that really uses it really well called Latexify. And Latexify is one of my favorites because it will let you just take expressions and turn them into code, into latex code. So one of my workflows for taking notes during class is to actually have like an open Julia REPL and just like type in a matrix and then Latexify it and then just paste it right back into where I'm taking my notes, right? Yeah, so the first time you run a package, it takes a while to precompile, right? So I will actually do, I think it's this. Oh, sorry. Yeah, so I have this, I just copy pasted this from somewhere else, right? Just like, let's say I have this matrix and then I will do Latexify on A. Oh my God. If I Latexify it, it will spit out the, hopefully, hello? Yeah, it spits out the, actually I should have auto-completed this. Yeah, so it auto-completes, then I hit tab again, and then I'm actually getting ahead of myself on one of my tricks. I'm gonna press up, and it will Latexify it. Yay, so we Latexified it. But there's actually like one of the really useful arguments, which is called copy to clipboard, right? And you just go true. And then anytime you go Latexify, it Latexifies it, and then you can just go straight up, paste it, and then you're good. So that's a really easy way for me to take notes. It's just like, how do I write this latex? And like, I don't care, Julia can handle it. So shout out to, I think it's Nicholas Crosbo, who's the author of that package, who's done like, he had a really cool JuliaCon presentation on it. So check him out. He's on YouTube. Send him some Bitcoin or something. Appreciate him. All the appreciation. It seems I've crashed. Yeah. All right. So we're back on. Yeah. So I've shown you some copying to the clipboard hacks, which are really cool. But now what I want to show is that there's actually one of these other hidden modes in the REPL if you've never bothered about it. It's called the shell mode. Please work. This is not the time to crash. Yay! Okay, it works. So if you ever press semicolon in the REPL, there we go. It will turn from red and it will tell you you're on the shell. So if you're in Windows, it will actually execute Windows code. If you're in Mac, it will execute Mac code. No, I'm on Ubuntu 18. So if I do pwd or I do cd or I don't know, tildir is one of the coolest packages ever. Tildir tar, it will tell me, you know, like the top 90% of use cases for the command tildir, and I'm like, oh my god, that's the greatest thing, go install it. Appreciate those people, right? So but the thing is that I'm usually working on Julia code and I'm like, oh my god, what was it that I had to do? And I have to like change directories, and I can just straight up do cd, and then I can do tab here and it will autocomplete. Yeah, so it will autocomplete, so I can just navigate all my directories and then like set up my packages and my code and step into, so I can edit this and I can do, hey, what is it that I was actually looking at? And you know, I can hop into Vim and, you know, just look at what I was supposed to be doing. So that's very useful. But don't forget that there's also these arguments called, there's these other functions that are called readdir, which is the equivalent, but it's a platform agnostic command to do that. So readdir will work on Windows and Mac and Linux. No, so you can actually do a bunch of like administrative scripting, right? CD will work, PWD will work. There's a whole bunch of them, but it's just really handy that you could just use these to move around. Okay, so back to REPL hacks. No? Oh, so a cool thing. If you didn't know this, you can actually like broadcast a function that was defined. If your function, so this means that if your function can be applied element-wise to a whole collection, it will be. So I'm going to do this. I'm going to press up, right, to go back in my history, and it will do, hey, this readdir function. That's funny. It gave me, it says an array of strings. What happens if I, apply foo to this function, which if you remember, foo would square the argument, and to strings it means it will, oh my god, it will fail drastically. So we will go back, and it will, for no useful reason, just concatenate every file name with itself and output an array of strings, if that's ever useful for you. All right, so I've told you that you can use the up arrows to like navigate, but what's really cool is that you can actually, let's say I called this command, and then if the next command I press is down again, it will go down from that command which I had reached via the arrow keys. So there's a couple of people that have hacked their presentations into the REPL, and so the only thing they ever have to do is just press down, enter, down, enter, down, enter, down, enter, and then their entire presentation will just follow that logical sequence, right? So that's a really cool hack. No, I usually use it if I want to show people off an example. So I'll just write out the commands once and then just go back to it, and that's it. I don't have to be copy pasting stuff. So if I ever, so there's this thing called the answer, right? Let's ask, does it exist? Does it have a doc string? I don't know if it does. Yes, it does. Variable referring to the last computed value. All right, so if you ever have something like, let's say, an array, right? Or you did some procedure and you ended up with that as the answer. This only works in the REPL. This is a REPL only thing. If you type ants, it will actually use that thing, right? It will display the thing that you had just used. But here's a really cool thing. The next command that you type will actually apply to that. So actually, let me define a different function, a different ants. Yeah, so if I do foo of ants, it will actually work. It should. It's a 2x2 matrix, right? So that's nice. That works. But what is really cool is that I usually use this to so you could, if you're working interactively in the REPL, you can just use ants everywhere, and it iteratively just like use the previous answers. But I usually use it to like climb the type tree. Like when I'm worried about dispatches, if you get to that, you'll know that sometimes you'll want to worry about where your type came from. So I just press up, type of, up, type of, up, type of, and just like navigate that way, right? So let's imagine that I'm defining a bit more of a complicated function. And this one's called my add, and then I will do for I in, actually I'm going to show you guys the super cool tab. Yeah, length of x. This function should have a mistake, and it should be very clear what it is, right? Yeah, so this function should add stuff within an x. All right, actually it should do, it should, yeah, just add up the things in an array, right? So I had this thing called the a, or the, what was it? I had defined the, yeah, this function, let's call it x. Let's call it y. So yeah, this is my y, and then it will clearly error, and the error will be my add for y. Sum is not defined, which makes total sense, right? Because I didn't initialize a variable that it could like add into the sum, right? So you usually have to initialize variables before you use them in a for loop. That makes sense. But if I didn't know, if I hadn't watched this video, I wouldn't know all the hacker tricks. But because you did, you will now be able to press Alt Enter, yeah, and you'll be able to add a new line into that, right? So that's maximum productivity hacking. I'll do 0 L type of X, dun dun dun, and then that will be a really cool example for, oh, it doesn't return. So I will do Alt Enter, and then I'll do sum. This is an implicit return. Yeah. So why was this? Yeah, the sum of 1 through 4 should be 10. Nice. But if I ever did my add of float 64, I'm broadcasting every one of you should now be a float 64, and this will work because they're all integer numbers. Bam! I will also get an answer because, and I was being really clever, and I was using the 0 and the L type. So if I go back and I do hello, yeah, if I do my code warn type, then I should get no reds. Union nothing tuple int 64. Oh, so I'd probably have to dig in a bit deeper there. Yeah. Oh yeah, because I didn't check for, I think it's because I didn't check for the length. And it's using like a small union optimization there. Probably. I don't know. But the point is there's no reds, so I'm going to call it a win. It's probably wrong, but whatever. There's another cool one, which is I think I just saw this. If you go in, like, because I read the man pages like 20 minutes ago before this video, you can do this thing with, I think it's Shift Alt and Enter. Nope. Hello? Control Shift Alt Enter. Nope. Ah, there you go. Yeah, if you just hold Alt and then you can move the lines around within the same definition, which is an absolute joy. If you just messed up the order, you can just go like, oh yeah, by the way, I just need to do pew 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 and move it around. So that's a really cool productivity hack. So this is another one that I started using recently, and it's really helped. Like if you've defined a command, like if you've run something in the REPL before, like you can actually change like the REPL history length so that you remain with a lot more lines in your REPL history. You can actually do Control R, and that will start searching back to stuff you use. So if I started wondering like, hey, what was this Latexify thing that, if you just type it and then you type enter, then it will like show you the first function, or the function that matches the most the string that you typed in. I think there's a bit more hacking you can do on that, but usually the first few characters will match whatever I was like trying to come up short with. So this is something really cool that I actually just learned because of the man pages. So if you see how I got an error mistake, I mean I got an error and then I got this stack trace, right? That the stack trace is like when it gets an error, it starts to like unwind where that error came from, who called it, from where was that file, yada yada yada, complicated compiler stuff I don't understand. So what you can do is you can say, oh no, this thing was defined in the REPL or in this file or whatever. If you want to step directly into the place where that error came from, you can actually just type in the number of the stack trace. So that's it. There's only one here, and then you can do caret key and then Q, and then if you do that, it should take you. It should take you into the stack trace. So let's try this again. I think if I do this and then nope. Let me Google this. Oh yeah, there it is. So I think it's Alt Q or Control Q. Let's try it again. So I do 1 and then Control Q, and then it calls up the editor. Yeah, so this will actually be a super duper cool productivity hack, if you're ever using revise, so revise is like a very, very useful development tool when you're programming in Julia, because sometimes you have code in a file that you want to update as you're like playing around the REPL, and then if you run into a mistake and this shows you, you can just do the using edit. If you don't want to do all those revise hacks, you can, and you just know the function, you can just do edit parse, right? And that will actually, please help me out, edit parse. Please specify type signature. So I will do parse, edit parse int. Please help me. All right, let's ask how you can actually do this. Edit. Let's do edit core. Edit base. Come on. Edit. Main. Edit parse. Okay, so there's a way in which we can call this edit on the function. No, let's, yeah, macro. Those are macro call turns their types in. Oh yeah, so I think if we try parse int 3, that should work. And then if I do edit, it will spawn up my editor and send me to the line where that thing was defined. Yeah, there we go. So I can now muck around on my code, and that's usually like a super hacker looking way of just like getting an error and then immediately calling the edit on that function and then stepping in. And if you have revise set up, then as soon as you step out, the code is loaded and you're ready to keep on iterating on your code. All right, so last thing before I go, this thing about having these different modes, right? You can tell that, you know, they switch colors. It's not something that's special in Julia per se. It's not like something only the devs will know and that you can never touch. There's actually like some cool packages to like make your own REPL. So there's one called this one by Mason Protter. I believe I'm saying that correctly. REPLMaker. Yeah, so you can just step in and, you know, cause your own REPL. So if you ever, and you'll set the colors and what it is that maybe you want to do a super cool wizard to help people out with some not so instinctive process. So one of the most used REPLs in Julia that people use quickly is the package REPL. I'm going to use it right now. And I started by using the closing square bracket. I hope it's well for you guys. Yeah, closing square bracket, and that will show me like my version number and like what my package environment is. So if I ever do add CXX, which is a really cool package that I'm going to show off right now, God willing, Cthulhuing, whatever. So it will add this package, no? But there's a couple of cool tricks that you don't, at least I didn't learn in the beginning of like, oh, I can just add packages from there instead of calling using package.add and then like adding all the strings. You can actually do tab completions there. What else can you do? You can ask for the status. You can test stuff. So usually Julia devs will be like dipping in and out of the package REPL to just like run the tests on an environment. No? You should probably go and look at Chris Rackauckas developing Julia package video to get more of an idea of what that workflow looks like. But I just want to say that you can do add C and then tab, and that will show you all the possible Julia packages that have been registered that you could probably download. So if I'm here, I can just do using CXX, right? And just to show you that, oh my God, so it doesn't work on this version. But if that had worked and I had pressed that, no, the less than key, then it would have shown up as a new REPL mode where I can type in C++ code, and it will compile, and I'll be able to like call it from Julia natively. So that, I think, is the entirety of my Julia REPL tips and tricks. So remember to get help with the looking at the doc strings, use the apropos, use the tab completion everywhere, work out some handy macros like, you know, at beat time, and then there's code and friends, which you can just tab into. The clipboard is really cool. You can use the shell mode. You can move around without the shell mode with CD and stuff, and you can print where it is you are. There's ands. Use the arrow keys. They're really useful. If you've defined a function and you need to move around with the lines, you can use Alt. And then if you need some extra lines, you can do Alt Enter. And then that's a godsend. Oh my God, yes. And then you can step into the stack traces with the number after it came out, and then the Control Q. And I think that's it. Stay tuned. We're going to be doing some open source stream contributions. And as always, PRs are welcome. Have a good time.